being involved with the class in other ways?
We're glad to be here, Mary. Thank you for having us. Don't get much of a chance to get in front of the students, so this is really exciting for us. We've been kicking this around for a couple of weeks, and we hope to kind of let you know what's going on and give you a chance to get involved later in the program. Just kind of an overview of what we're going to talk about. We're going to discuss why sustainable building practices are important. We're going to give you an overview of the LEED rating system, a brief review of the intent of each of the credits, and then finally we're going to ask you to participate with us on determining whether or not certain credits, we're not going through all of them, but we picked about 15 credits to look at in depth as they relate to a couple of projects that we're working on, specifically the stadium and the other side there, Quealy Hall. And so hopefully you can help us figure out whether it's worthwhile to pursue those credits. So, what is a green building? Is it this? Yeah, that's a green building. But some people think to be green, you have to be very modernistic. In reality, right next door, the first green building on campus was Weinstein Hall. And as you can see, the two don't look anything alike. So we can achieve LEED or green building practices, sustainable building practices with a style of construction, a style of architecture that you don't necessarily think you have to do, i.e. the modernistic style. So I'm going to pass this on to Trey.
Being a sustainability coordinator, I get to talk about all the bad things about buildings and how we can improve. So, in the U.S., buildings, conventional buildings, account for roughly 40% of the total energy use in the country, 14% of the total water consumption, 72% of our electrical consumption, and 39% of CO2 emissions. It also contributes quite a bit to our solid waste stream. If you look at from cradle to grave of a building, roughly 66% of non-industrial solid waste is as a result of building and building practices. Furthermore, Americans spend about 90% of their time indoors. Indoor pollutant levels are anywhere from 2 to 10 times what they are outdoors, and sometimes they can approach 100 times. And in schools in particular, 20% of U.S. schools have reported unsatisfactory air quality indoors. So why build green? Well, to counteract some of these points that we just made. First of all, green buildings and green building practices save resources when you compare it to an average building. Consume less energy, maintenance costs are lower, occupant satisfaction, occupant health is higher, and green buildings produce roughly a third fewer greenhouse gas emissions. Green building occupants are also healthier and more productive, although I don't look like that. Studies have shown that there's a range of total health gains anywhere from $17 to $48 billion, and similar gains in worker performance. It also saves money. So even if you don't buy into the environmental benefits, there are definite monetary benefits as well. Operating costs decrease. The values of buildings actually increase, as do the returns on investment. This brings us to green building rating systems. So you get all these benefits from green buildings. So why can't a builder go out and say, "Hey, my building's green"? How can you tell, unless you're an engineer or an architect, whether a building truly has these green features? That's why you use a rating system, because it provides third-party verification. You take what you've done and you submit it to a third party that reviews it and verifies what you've done. And so therefore it's reducing greenwashing. Is anybody familiar with the term greenwashing? is going to be interactive. Sorry.
It's basically working what comes out and says that they're doing something that's really fun. It's really not a diverse attention from actually like proactive initiatives.
Perfect. That's exactly what it is.
Do you think that's happening more or less now that this is being more accepted?
I have no idea.
More. No doubt.
I have a feeling personally that there's more of it going on. I mean, just look at the advertisements that you see. Everyone is green. I would question some of that.
So some examples of the rating systems. Here's the Living Building Challenge, the National Association of Home Builders, and Green Point. But the two that are best known are Green Globes and LEED. And LEED is the method that was chosen for the University of Richmond buildings. And to give you a little history about that, I'm going to let Andrew discuss it.
That's right. Little history. We did our master plan back in 2000, and there was a small group, I mean a handful of environmentally sensitive faculty, staff, and students that petitioned our president, who was Bill Cooper at the time, to get into this newfangled program called LEED, which stands for Leadership in Energy and Environmental Design, and to accept. They pushed us at the time to build all of our buildings to the gold standard. This was a relatively new standard. It was set up in 1999. And so during the process of going through the master plan, there were a number of committees that heard a bunch of things, and it went to the Board of Trustees, and the Board of Trustees said, well, you know, there's all sorts of competing resources. There's money to be worried about, etc. And so we wrote into, at their direction, we wrote into our master plan that we would pursue LEED points as much as we could, especially as they reduced costs within reason on a payback basis. They also said that one of the university staff had to become a LEED accredited professional. Well, that fell on my shoulders. And so we pursued that. Why did we choose LEED over something else? Well, it was basically the granddaddy, and it was what was available, and it has since been more or less accepted by higher education as the standard. So that's why we chose it. We'll get into a little bit more of the overview here in a second. So, I told you what LEED stands for. It's divided into 6 major sections: sustainable sites, energy and atmosphere, material and resources, indoor environmental quality, and then innovation and design. We're going to talk about the specifics of each, but kind of a quick overview. Sustainable sites is making sure that you're building in appropriate areas. The water efficiency, kind of, it's self-explanatory, obviously, don't waste water. Energy and atmosphere, we want to make our buildings efficient. Materials and resources, use appropriate materials, and we'll get into that shortly. Indoor environmental quality, basically creating indoor environments that are healthy. As Trey alluded to earlier, we spend how much time inside? 90%. So, you know, obviously being outside, that's where the fresh air is. So we need to make sure that we're not trapped in an area that is not healthy. They give you, under the 6th one, Innovation and Design, they give you a chance to get some extra credits for other areas such as exemplary materials. There's a number of them that you can go for, but essentially it's doubling what the requirement is. We've identified a bunch of other kind of new things like LEED education. This kind of would be part of it too. And then the levels of certification, as you can see, they're here. You know, we signed the President's climate commitment, And by signing that, we have agreed that all buildings that we build from here on out will meet the LEED Silver rating, which under this current rating system, which we're showing you 2.2, and the buildings that we have on campus that we're building right now were registered under 2.2. Once we get through those, our future ones, they're on a different rating system. And I think, Mary, I wrote a chapter for a professional organization that identified all that. And I think there's a handout that compares where LEED is now, or was, and where it is now. Let's see. So I'm going to talk about the sustainable sites kind of overview. First one is the prerequisite. That means you got to get it. If you don't do this, you don't get LEED, period. All prerequisites have to be met. Basically, there is a lot of pollution from runoff during construction. Erosion is a real problem. You can see it in streams sometimes where after a big rain, the water is very muddy. So we have to follow Chesapeake Bay Act regulations for construction with the City of Richmond. And so we meet that. The next one has to do with site selection. And in site selection, there's a lot of specifics, but basically, you want to build, you don't want to waste land. One of the things I want to get across about sustainability is that you're not wasteful. Now, with land, we don't want to be wasteful. You get credits for building in areas that have already been built before, as opposed to raw woods or whatever. You want to make sure that you're not negatively impacting waterways, where you would end up building in a wetland. The next one is development density, community connectivity. And one of the things here is the benefit is we're like a little city. And little cities want to encourage walking. So we can get credit for, we're going to go through this specifically later, for having different things within a half a mile of our site. And what would some of those things be? Restaurant, churches, libraries, things like that. So we're going to, as we get further down, we're going to ask you some of these things. The brownfield redevelopment, we don't really have any of those here, unless I think maybe we tore down our steam plant and built on it. VCU happens to have one downtown near the railroad yard. I was involved in that. Basically, it's cleaning up bad sites, and you can imagine why that's a good thing. The next four all deal with alternative transportation. The idea here is that we're trying to encourage people carpooling, riding bikes, less use of fossil fuels, and you can imagine why that's a good thing. The next one, site development, protect or restore habitat. Basically, on this is when you do develop a project, to limit how much of the site you're affecting. Why? Well, obviously, you're scarring the land and you're affecting the critters. So we want to make sure that we're not taking more than we absolutely need. The next one is creating more open space. And the open space is a good thing because it creates space for habitat for the critters. We just went through this with our board. The next two have to do with stormwater management. The first one is quantity control, so you're not overloading the system, which goes into the James River, which causes flooding. And the second one has to do with quality. So you're trying to not let phosphates get in there and suspended solids, i.e. the erosion that you see from sites. The next two having to do with heat islands. Does anyone know what a heat island is? This would be the give and take. Anyone?
You have a hand in the back.
if you got a thermometer in your car and you're driving around, I know this, that when I'm out in the suburbs and there's lots of green space, it'll be cooler than if I drive downtown. It can be 5 to 10 degrees cooler. Why do you think that is? Anyone? Go ahead.
It's just all like the urban surfaces in like the city will absorb heat a lot more than the natural surfaces.
Exactly, that's a heat island. And it can affect your microclimate. So if you had a lot of heat during the summer and it's being absorbed, is that a good thing or a bad thing? It's bad because it's adding to the heat that you're trying to air condition out of your buildings. So we have heat island effect for non-roofs, so that would be all the stuff around the asphalt or the sidewalks or whatever that are dark and absorb that heat. And then you have heat island effect on the roofs. And there are roofs that reflect it and there are roofs that absorb it. So obviously absorbing that heat would be bad if you're air conditioning. And then the last one is light pollution. Light pollution is, as you're kind of going through this, and this is just dealing with sites, you kind of get a quick feel for that this is not just tree hugging, okay? This is kind of all-encompassing. To me, it's just doing the right thing. Whether you believe in global warming or not, it's doing the right thing. And the right thing with regard to this is if you try to go out and look at stars in the city, it's pretty hard. Why do you think that is? Excuse me?
Because of the many lights.
Exactly. You have to go way out in the country to be able to see the clear sky. You've seen these pictures, I know, of from space, and it's like this giant globe from Boston down to Washington. And one of the things that LEED is trying to do is to get rid of that. It's very obnoxious to live in your house and you have lights coming from your neighbor's yard or something like that. Well, the same thing goes all around. All right, I need to pass this on to Dave.
The water efficiency credits are broken up into 3 credits. The first one being everything outside of the building, aka landscaping. We can do that mainly by using native adaptive plants, trees and shrubs, which we do a pretty good job here on campus. We don't have a whole lot of irrigation on campus. As beautiful as the campus is, we try to use the native plants as much as possible. The second credit is the innovative waste water technologies. That's more talking about gray water usage, anything having to do with your toilets or your showers, where you're actually putting stuff down the drain. We'll talk more about that a little bit later. And third is overall water use reduction. You're just trying to use low flow shower heads, faucets, dual flush toilets like some of you have in your dorms. And we'll talk more about that. The next section is the energy and atmosphere. And mainly what that is just the first credit is you're trying to have a very energy efficient building, whether that be through having a lot of insulation in your building, high performance glass, efficient HVAC, efficient lighting controls. That's the core of this section, along with credit 2 on-site renewable energy. That's your solar panels to make electricity, hot water, that sort of thing. Also credit 4, enhanced refrigerant management. That's just it's rewarding you for using refrigerants that aren't ozone-depleting our environment. And we'll talk more about measurement verifications. So I'm going to pass this on to Trey.
Then we get to materials and resources. There is one prerequisite, and as haphazard as they might be, there are recyclable bins throughout the buildings, particularly in the ones that meet LEED certification. But overall, this category is about it's again about reducing waste. In this case, it's about reducing material waste. So it encourages the reuse of buildings. So instead of totally tearing down a building, LEED gives you credits for reusing, for example, the structural elements of the building, the walls, the ceiling, roofs, what have you. And a great example of that is the rec center. We'll talk a little bit about that later on. Construction waste management is another one we'll discuss in depth. You get points for diverting 50 or 75% of your construction waste. And you think about what we discussed earlier, 66% of the non-industrial solid waste in the U.S. is from buildings. If we can recycle or divert from landfills 50, 75% or more, which we've been able to do on some of the projects around campus, that's going to take quite a load off the landfills. Recycled content has to do with new materials that are going in. If you do have to buy new materials, look for ones that have higher recycled content. Regional materials refers to materials that are both extracted and manufactured within a 500-mile radius of our project site. And then rapidly renewable materials, you probably have all heard about bamboo flooring or wheat board, bleach strand cabinets and so forth. These are made from, these materials are renewable. They come back, they can regrow within 10 years. And then finally, certified wood. Some of you may have heard of the forest stewardship certification. You have to use a certain percentage of FSC wood in your projects. And I will not go over each one of these individually because then you'll be wiping drool off the desks. But indoor environmental quality, getting back again, not to belabor the point, but we spend a tremendous amount of time indoors. And these credits are all focused on how do we improve that, how do we improve occupant health, how do we deliver fresh air, how do we get daylighting infused to people who are inside, and also how do we help, or how do we allow building occupants to control the things in their environment to some degree, to make it more comfortable. How can you control the temperature? How can you control light in your spaces? And there's also a credit for verification. We actually survey the people who are in the buildings. And if any of you are in Lakeview, you got that survey, so I know you did. So, so we do want your feedback. It helps us help you. Anyway. And Andrew can talk about innovation and design, because he does the design.
Well, as you can see, there's 4 different areas of innovation and design, at least with this particular version of LEED. There's more. You just have to get it accepted by USGBC. These are some examples of what we've got approved in the past. Exemplary performance, like I said before, that's where in a number of credits, it might be like 14, where if you do twice as well as what the credit is, they give you another point. Green housekeeping is an example of what we've been doing. And basically, you're using chemicals that aren't poisoning us. Integrated pest management is an example of one that we've gotten that is basically preventive in nature. That you only get into poisons and they're less toxic to humans at the last stance. You try to solve the problem by not leaving food out, by closing up gaps in walls, etc. Changing how we're the ones that are causing it, so changing our behavior. And then LEED education. We will do this on a number of occasions for specific buildings. We might create, you may have noticed a poster that we created over at Highland Dining Center. And then you get another point for having a LEED accredited professional. And by the way, all these guys are LEED accredited professionals too. So, and it's not an easy exam, as I understand. I got mine a long time ago. I don't think I could get it now because it's a lot harder. So, LEED at U of R. 531 certified buildings so far, according to Trey, as of December. And there's a gajillion of them that are registered. We have a gajillion ourselves, so make up that 3,000 and whatever. But, you know, back in 2003 is when I made the application for Weinstein Hall. And Weinstein Hall, by a week, missed being the first higher ed building in Virginia. ODU beat us by 1 week, which was a little frustrating, but we got bragging rights for Central Virginia. We were the first building in Central Virginia to get LEED accredited. So we were early acceptors and bought into the LEED process. And by the way, it's LEED, not Leeds, Dave. Leeds is a city in England. As I said before, by President Ayers signing the President's climate commitment, we have committed the university to building to LEED Silver or better. We have 9 buildings on campus that have been designed under the LEED standards. 2 are certified. I mentioned Weinstein Hall back in 2003, and Highland Dining Center. In addition to Highland Dining Center got its LEED certification this summer, we have a big backlog of projects. Lakeview, Weinstein Center, Freeman Hall. Anyway, so we have 4 that have been completed already that we're working on the applications. And this is one heck of a long and drawn out process. We applied for Weinstein Center in September, and we're still going through the design process or the design review. We should go through the construction review shortly, and hopefully, knock on wood, we should get that Trey, what do you think, later this spring? We hope. And then, of course, you've seen a little construction going on. So those have all been designed according to LEED, and as we do more and more of these, we're getting better at it. We made the decision long ago to do this in-house. Many universities hire consultants to take care of this, but we think that we have a lot more control and we can wear a lot more hats. And so it's a very cost-effective way for the university to get this LEED certification. UR Downtown is a building, what's the address? 7th? Yeah, I guess 6th Street's over here, 7th Street is there. It's an old bank building. It was gutted and renovated according to what LEED shell, and our interior was designed according to LEED standards. And there's a picture of it inside. So here we are. There's Highland Dining Center in Weinstein Hall. And here obviously are the buildings that we've got that we're working on. This one currently, and this one, and we'll be hitting this one next, and then that one, and then the projects that we've got. It's just a long drawn-out process. And here are the projects that are still under construction. We're going to talk about those. All right, it's me still? Yeah. Still me. Oh, look at me. All right, well, obviously we've got Robins Stadium over there and Quealy Hall over there. And we're going to take this through. Like I said, we've got about 15 credits that we wanted to talk about. And we want involvement, so please don't be shy. Remember I was talking about the community connectivity. First of all, why is it important? Why is community connectivity important?
Accessibility, walkability.
Very good, Robert. Very good. Anyone else? Okay, well, Robert hit it on the head. I mean, basically, you want communities that are walkable. You know, how many people really walk around here? I don't know. But we should. So here is Robins Stadium, and it's half mile radius, and you know there isn't much difference. You can see how the circle's shifted over, but here's Quealy Hall. All right, starting naming off some things that you think are stuff in a city that you'd want to go with. Ice cream, well, all right, that's a shop, okay, right? Or a restaurant. Okay, so someone keeps score. We got to get 10 of these to be able to get connectivity. So where can you get ice cream or something to eat on campus? Highland, dining. All right, are these within the half-mile radius?
Yes.
Yes, okay.
Library.
Huh? Library, very good. Is it within the half-mile radius? Yes. Come on, let's go.
Fitness center.
Huh?
Fitness center.
Fitness center, yes.
Green space.
You keep it up here? Huh? Who said what?
Evening space.
Green space?
Green.
Okay, it'll be a meeting space. Meeting space.
Meeting
Church.
space, living space.
Very good. That's where I was going to go. Where do you meet on Sunday? Thank you very much.
Although meeting space, but
Okay, we'll put it down. All right. Okay, good.
post office.
Post.
Dorm.
See, I got the audience stacked here. Housing, someone said housing. Very good. How many are we up to? 1, 2, 3, 4, 5, 6, 7.
The doctor.
Doctor, very good. Is it within?
I don't know.
That's too
All right, hold on. Now this is where the controversy starts. Where is?
It's too far for Robbins, but it's not too far, really.
It's down.
All right, I got to find it.
Okay.
I think I know where it
It's
is.
on the boat.
Right here. Is that it? No, that's not it.
Yeah, that's what
That's
it
it.
says.
Oh,
Yeah, that-
yeah.
Sorry, doesn't count. Next. Come on, guys. We got how many did you get?
Education.
Okay, cool. It's all over the place, right? So that's a no-brainer.
Tennis courts.
Does that count? Tennis court?
It's part of fitness.
Fitness. Sorry. Next. Transportation. No, that's under a different thing.
Coal-fired power plant.
Who said it? Next. Come on. How many more do we need? Oh, yeah, we're not going to get this.
A lake.
No.
Wild
How about a
lake.
store?
Okay, yeah.
Where's that?
Fair.
Okay. All right. Bookstore.
Oh, a museum.
Very good. I like that.
Peter.
All right, what? One more? Are we almost there?
Somebody just said
Peter.
Yeah.
So, yes, no?
Yes.
Yes.
Okay, good. Thank you. Thank you. Okay, parking capacity. Is this me or is this Dave?
All right, I'm going to go to the rule book on this one. But we have several options on this credit. And on the left, obviously, is before construction. And on the right, it's the same parking lots shown on what it's going to look like afterwards. So let me read you the criteria and what you guys decide. All right, option 1 is to size the parking capacity to meet but not exceed local minimum zoning requirements,
and you all know what those are, right?
and to provide preferred parking for car pools and van pools with 5% of total spaces. Or you can provide parking for 5% of the building occupants for the car pool and van pools. Option 4, because 3 is for residential, is to provide minimum parking.
Okay, that's the one we want.
That's the one we're going for, so just eyeballing it, not knowing specific, space count. What do you guys think? Is it close? Is it, look like we might get it? So we guys, what you're thinking about that, here's Quealy Hall. So between the two, what do you guys think? Yeah, it looks pretty good. It looks like we're actually taking away a few spaces here. This looks like we got smaller, so we're actually not providing any new parking. If anything, we might be taking a few spots.
All right. Dave, I'm going to disagree with you. I'm going to agree on Quealy Hall because we have not provided any parking, so that clearly meets that. There's the site. Here's the business school. Here's Quealy Hall. There's the faculty staff parking lot for the faculty staff. And then there's that lower parking lot that I'm not sure is visitors or faculty staff, but we're not adding anything. We don't have any land up there. That project is like an aircraft carrier. There's no place to build. So there is none. But Dave thinks that because there was a parking lot across from the law school, we haven't added any new parking. Well, Dave, I disagree because you guys probably don't know, but this was a free-for-all. There was no lines. It was just asphalt, and the trees were still there. So it was just all around, and the law students would park in there, and they knew who came early and stayed late, and someone else would park behind them, and they knew whose car was what, and they would just jumble them all in there, all haphazardly. I couldn't tell you how many parking spaces there are. Now, not only are we putting in parking, but we've actually expanded it. So we're actually going to create a parking lot over there that will have 66 spaces. Now, if you were a lead guy reviewing all this information, and you see something here that really has no credibility as far as how many cars are in there, whereas on this one we have to because we had to build it to city standards, it says 66. So you trust me? I don't think so.
Are they going to know that that was just free-for-all parking? Like, how would they know that?
Well, we would have to show a document. Dave would have to draw this up. And I guarantee you, if Dave drew it up to the appropriate standards, allowing 9 feet and wide for a parking space and 24 feet so that you could pull out, you'd probably get 30 cars in there at that. So 66 versus 34, did we add parking?
But you also said so.
Not enough, I don't think so.
I don't know. I think this one's
Well,
up for longer debate.
We'll see.
So did you designate some as like van parking, carpool parking? Is it not?
That's a different credit though. Well, no, that's true. Oh, I am very impressed. So we were focusing in on the one option. So very good, I like that. She should be a part of it.
That's why we're doing that.
Okay, so enough on this credit.
De facto job interview. All right, this is fine.
Okay, take over.
I understand on this side, just so I can gaze upon you all. Okay, heat island effect, we already discussed briefly what it is. Since neither one of the buildings that we're talking about is finished, and you can't gaze upon their roofs, we don't have any photographs of them, we had to find some analogs on campus. So we're going to look at the rec center roof. We're going to look at pretty much every other roof on campus, the steeply pitched slate roofs. So the idea behind this credit is that, not the idea, but the criteria for this credit is for a flat roof or a very shallow pitched roof, the roof, its material has to have a solar reflective index, or SRI, of 79 or greater. What does that mean? Does anybody know what this solar reflective index is? Robert, you seem to know everything else.
I was just looking at the answer, so I'm not going to.
Basically, the SRI is a measure of a material's ability to absorb or reject solar heat load. It's a fancy way of saying how much can it reflect. And it's on a scale from 0 to 100. Black would be 0, and standard white is 100. So looking at this, do you think, first of all, do you think the rec center would pass? I mean, there's no way for you to really know, but just eyeballing, what do you think? Yeah, okay. So it is. It averages over 79. So we know we're going to get that credit for the rec center, and therefore most likely for the stadium because it's going to use a similar material. Yeah.
You don't need to take into account the asphalt in the parking lot.
That's heat island
Non-roof.
Okay.
This is specifically for the roof, but good question. Now let's take a look at the slate roof, the ones that are already on campus, and the one which are similar to what's going to go on Quealy. Now for steeply pitched roofs, the SRI only has to be 29 or above. So, what do you think? Think we're going to meet it?
Yeah.
Well, that's what we thought, but it's only 19, and we wanted to argue it, but we actually went to the manufacturer, and they have been improving, it's getting better, but the particular slate that gets used across this campus does not meet it. So, the stadium will get it, unfortunately, we won't.
I also think that part of the problem with slate is it's coming out of the ground. When they're testing it, it's brand new. You know, I mean, brand new is a product out of the ground can be. But as it's out in the sun and the weather, I think it actually gets lighter. And, I was amazed by this picture. How could that not be reflective? It looks almost white when you look at it from that point of view.
What if you actually want to utilize a lower SRI for the building itself, to heat the building? Would that change getting credit for it?
I don't understand.
Like if you actually wanted to use a darker roof in order to heat the building and cut down extra costs somewhere else?
And LEED doesn't work that way. It's kind of a give and take. Yeah, you might be able to, in that particular instance, we're in a really, if we were in Alaska, it might make sense to have a roof that absorbs heat. But here, shoot, we're 50-50 between maybe more cooling than we are heating. So we actually would be penalized for that. Well, not penalized, we just don't get credit.
Yeah, and that's what the reviewers would say, or that's what you can actually apply for a credit review. And they will say, it's a wonderful thing, but it doesn't meet the intent of this particular credit. You can't, unfortunately, you can't substitute like that.
And there are a lot of credits. There are a lot of credits in LEED that contradict each other. You could get it for this, but you wouldn't get points for doing this, or vice versa. So it's not meant to necessarily get every point. You can't do that. Go ahead.
Now we're talking about wastewater technology, and it is innovative. You got to try to think of something new, something that's not very popular right now. But it's broken into two sections. One is reducing the amount of potable drinking water used for wastewater. For example, your toilets, your washing machine, that sort of thing. And the other half is treating that wastewater on site. So here we have a diagram. Here's your big tank that you take all your rainwater off the roof, it goes in this big tank, gets pumped up here, and then from there, you serve your toilets, your washing machine, your spigots, you can irrigate. We haven't gone for this mainly because all of this extra piping adds cost to the job. It becomes very cost prohibitive. Other technologies are Andrew's favorite, composting toilet. And actually construct a wetland, but that takes a lot of area, which take Quilly Hall for example. There's not a whole lot of area around the building, or the fitness center. Plus, maybe you have to deal with a whole lot of other issues. Moving on to water use reduction. How many of you guys have used any of these fixtures out on campus? Okay, what do you guys think? Do you think they work? So these are some of the things we're probably going to use in Quilly and Mississippi. I know we're not using wireless urinals so much just because we found that the maintenance is pretty high on them, and they don't work as well as we would like them to. So we use a much lower water amount, a pint, which is 1/8 of a gallon, versus 1.6 gallons. So it's still a great reduction, but we do use water for units. Shower heads are typically 2.5 gallons and 2.5 gallons per minute. The low flows are 1.5 gallons per minute, so it's a lot less water coming out of the shower head, which might upset people. It's 40% reduction, but low flow faucets, it's not difference. People will need rooms out. And dual flush toilets, we have in Lakeview, so some of you have already probably used.
I bet most people wouldn't even notice the low flush shower because of the aeration. If you hadn't told them.
So we think we're going to get these on both of those projects.
Yeah.
We've incorporated these technologies, which will save what, say 30%?
Yes, we anticipate getting 2 points. You get 1 point for 20% reduction, 2 points for 30% reduction, and we anticipate that on both of the projects.
Let me interrupt you for just a second. It's hard to imagine with all the snow and the rain that we've had, a problem with water. But I can remember a few years ago where we were in a drought. In fact, UVA said they only had 6 weeks of water left, and they were going to have to close the school. So, again, to me, LEED is about, or sustainable building practice is about not wasting it. So why waste water when it really has no impact on our usage or our experience by reducing the use?
Next, we're going to talk about optimizing your building as far as energy. These are the big, items. Your HVAC, getting efficient systems. Low consumption, lighting, high performance glass, and building insulation, which is this blue stripe right here. But what are some other things that you guys have seen on campus or elsewhere that could help us be more energy efficient?
Very good. Occupancy sensors. Where are some problems? I know some of you live in some older dorms. And what are some of the problems in your particular room?
I have really thin windows.
Very good. Exactly.
Inside of
So where's all that heat going?
right outside.
Outside. Exactly. That's called air infiltration, or in this case, it's infiltrating the outside. Exfiltration.
Some of the other things that you may not think about are just adjusting your set points. Instead of having the room at 72 degrees in the summertime, bump that up a few degrees to save energy. We do that campus-wide down in the facilities. We have one person who manages that all day, sits in front of the computer, and is constantly changing set points to try to save energy as much as possible. Other things are carbon dioxide sensors. And what that does is senses people in the room, and so if there's nobody in here, the HVAC system can, go to a more efficient operating state. And when people come in, they'll come back up and back up. You'll still be comfortable when you save energy. So these are some of the things we'll be looking at when we do the energy audit, people in the class later on this semester. And I just wanted to share this technology over at the Robbins Center. It's fairly new in the States. So just envision this being an office building, and this area right here being Andrew's corner office with big windows and a nice spacious office, and think of it like a spring morning where you have lots of sunlight coming in. Well, that room is going to start to get hot, and there's already hot air in that office, so we're going to take that hot air and channel it over here where Trey and I sit. It's still pretty cold back there in the dungeon. And we're going to reuse that energy and make it a very efficient system. So we have this in the stadium. We also have it at the West Hampton Center.
Now we get to the fun one. So you can get up to 3 credits within the LEED rating system for on-site renewable energy. So on-site renewable includes wonderful things such as solar PV, wind, geothermal, etc. So what do you think? Do you think either one of our buildings are good candidates for renewable energy?
Go ahead.
Yeah. Just these two. Just these two. The two particular you came in with. So we're focusing on the stadium and Queeley Health.
Yeah, Queeley's got a sloped roof, and the stadium's got flat roofs.
But you also just made a really good point. What was it?
Do we have fun?
A lot of trees around Queen. Okay.
The stadium is far over, and I mean, it's a little taller than a lot of the buildings, so there's more room.
Okay.
I would imagine overall energy, the stadium would be pretty low, since things get turned off and people aren't using it, so like you can hit 12.5% for ease.
Okay.
Well, I feel like neither of them would be good for either wind or solar, because the stadium has not a large area of space that you can use. And again, Wheelie Hall is covered with trees, and there isn't much wind in the state of Virginia to really utilize wind energy.
Okay.
You do have an interesting asset in the lake there. You could consider doing geothermal with a ground loop in the water.
Yes. We are actually, we're actually looking at that for the climate action plan. But for these two particular buildings, they're too far from the lake for it to be financially viable whatsoever. But it's a really good point. To get this moving, Zach's absolutely right. We don't have the wind around here for turbines, and small turbine technology has not reached a point where it's efficient enough for us to even really consider it. Which leaves, for these two buildings, pretty much solar PV is the only option. All the negatives, well, for PV anyway, that we've discussed about Wheelie are exactly right. It's too shaded, it's not a great location. So it's really not a good candidate. However, the stadium is, and you would be surprised there is enough roof space that we could get to 12.5% and even more. So it's not a no-go, it's something that's under investigation. So
The challenges are payback.
that's one of the challenges.
That's a huge challenge.
I will debate that with you, but we got way too long. So we should move on. Dave, back to you.
Okay. I'm going to go through this real quick. Right here, these are the two drawings from each project. And I'll just explain. We've got power coming from the Virginia comes in, gets distributed to the west side, to the east side, to the stadium, and then from there it kind of branches off into a whole lot of different things. Anywhere from HVAC to your lighting to your receptacles. Over here at Wheelie Hall, same thing. You got power coming in. It gets metered when it comes in, and then it branches off. And you can see everything's kind of divided a little bit more. So the whole intent of this credit is to be able to take the energy model numbers and actually compare them to actual data. So based on what you see here, which, if any, do you think of these projects likely get this credit?
Let me interrupt for just a second. By specific use, in other words, you can measure how much energy is being used by the HVAC system. You can measure how much energy is being used by the lighting, how much is being used by receptacles. All right, now with that, which one do you think, or do they both need it? Or do they not need it?
I'll give you a hand. It's got meters.
Well, the other thing is, specifically, Dave, is that you come off of here and all of this stuff, all this power that's going here is one type of stuff. It's HVAC. The power that's coming off of this is lighting. The power that's coming off of this is receptacles. Whereas over here, it's all jumbled up. So with that, which project is going to get this credit? Clearly. All right. And the issue here is distribution. Just like on that slide where we were looking at the distribution for gray water or using stormwater to flush things, you had to have a whole additional distribution of that water. Well, think of electricity as water. We have to have separate distributions so that we can meter that energy, whereas over here, it's all jumbled up. So which one's more expensive? Wheelie, exactly.
This will be the first project on campus where we're actually attempting this credit. So we're pretty excited.
And one of the reasons why is because we got a donation to pursue credits like this from a donor. Construction waste management, you can see here what you can get points for. There's a lot of trash that comes out of buildings. You know, stuff is boxed up, you've got a lot of waste. So, you know, based on that, do you think we can get this? Do you think it's maybe or none at all on our projects? Any ideas? None? Someone said none? Anyone think we can do it? Okay, thank you very much. Basically, this has evolved over time. It was a real challenge. And just recently, this has been accepted by the industry, the construction industry, as being standard operating procedures. When we were building Lakeview, which was only open 2 years ago, we had to put piles and segregated, you know, metal, masonry, etc. And then they would come and we would put it into dumpsters. Once we got to Freeman, which was the next project later that spring, so basically a year and a half ago, they would bring the dumpsters and we would dump them into the dumpsters, but it was still segregated. And we had to have a dumpster Nazi to make sure, or a czar, to make sure that no one was putting stuff in the wrong dumpster. And now, this company in particular was the first one in the area to create a sorting thing. So basically, you can put any trash in their dumpsters, and then it's sorted, and that will give you a report. So we're actually getting reports of like 95% diversion, which is fantastic. You know, whoops, when we tore down the stadium, we actually crumbled it up, and it's underneath that mound of dirt near Lower Robbins Court as a fill product. The other one that we want to talk about is materials and resources, regional materials. Okay, so the deal is you want to get products that are within 500 miles. Well, you can see the 500-mile radius goes up to Vermont, out to Indiana, down to Georgia, and in between. Now, why do we want to promote this?
Travel time. Fossil fuels.
Fossil fuels, right. The closer it is, the less we're polluted, okay?
And it also stimulates regional economy.
Very good point. So, what do you think? Do you think there's a lot of materials that we can get within this zone or not? Do you think this a lot of the stuff we're getting is from California and China? Anyone?
Hopefully not the drywall.
Ah, jeez. Come on, come on.
Yes.
Yes, okay. Well, we get concrete that's recycled and steel. There's this recycled steel plant where a lot of the structural steel comes from, just 30 miles south of here. Concrete, they break it up, they put it back to make new concrete. Drywall is up in Pennsylvania. Brick is all around here, Virginia, Pennsylvania, North Carolina. There's a carpet plant, believe it or not, in Galax, Virginia, but even if it's out of Dalton, Georgia, well, that's within the range. Slate comes from Vermont. It just depends. The limestone that we have comes from Indiana, and it just depends. Sometimes we get it right there, and sometimes we get it right there. So it really gets that close when we're looking at these things. So we get this. In fact, we think we get exemplary performance on these. Who's got this one? Dave? How are we doing on time?
About 10 minutes.
That's good. All right.
Good day. IAQ during construction. Construction in general is a pretty messy process. And so, especially when you're finishing sheetrock, it's a huge cloud of dust everywhere. And so one of the things you have to worry about is preventing that dust and debris from entering the HVAC system or other systems, and then coming back out once the people, the occupants, are in the building and construction is done. So this is a picture of ductwork full of sheetrock dust, and this is what it looks like clean. So what are some of the ways we can
those.
A lot of times,
It's
Well,
all,
between Quealy Hall and Provinceville Business.
but what about Quealy?
You just talk to the doctor.
Whoa,
there you go.
that's a good one, exactly. What's another problem that people are allergic to? You know, I'm allergic to dust, but there's something else that's out there, mold. I don't know, I get into a room and if there's mold, I go, my nose, you know, there's a lot of water in a building under construction until they get the roof on. And people will store, these are construction workers, they'll store stuff in ductwork sometimes is insulated on the inside of it. And just think what would happen if it's sitting in a puddle of water, the insulation's getting saturated. What grows in dark, wet places? Mold. Okay, so obviously, in addition to covering it, keep it up off the ground so it's not being, you know, in a pile of water or a puddle of water.
Also, you know, adding filter fabric anywhere that air would go into on HVAC systems that are operating during peak.
Okay, so can you help me?
Oh, yeah, here, go ahead and talk.
So,
Open that up.
yeah, open them up.
Smell it.
And pass it on.
And
This is the
pass it around.
learning a little something about
The
presentation.
scratch and sniff part of the
Learning a little bit about presentations too. You try to engage every sense. So you've had auditory, you've had visual, you've had taste. So now you're going to get the olfactory. What's it smell like? Or what's it supposed to
What's the
smell
name
like?
on it? New car smell.
It smells like a new car or a reasonable facsimile thereof. Is this a good thing? Not this in particular, but just the new car smell. You open the car door and you got your brand new
Wow, this is
2010 Maserati. Do you love it? Yeah. But
Some
is it
yes, some
good?
no. Anyone yes?
Is it a good thing?
No.
It smells good. Why is it bad?
Chemical.
It's chemical. What specific chemical? Well, the one that we really focus on are the VOCs, volatile organic compounds. And these are toxic. They're carcinogenic, and they're given off at room temperature. So these four credits deal with materials that could possibly contain or off-gas VOCs. 4.1 deals with adhesives and sealants. 4.2 paints and coatings. Now these two, there are so many different applications, so many different places you can have sealants and adhesives and stains and so forth. There is not one specific number that the VOC can't go beyond. So we actually have to reference a rule from California that goes through about 50 or 60 different materials and tells us the limits for each one of those. For the carpet, one, you may not even realize that the carpet, at least older carpets, would off-gas ridiculous amounts. But the carpet systems have to meet green label standards. And then finally, wood and agrifibers, they can't contain any added formaldehyde, urea formaldehyde, because that's one of the substances that actually does off-gas VOCs.
So from a architect's point of view, in an owner's point of view, here, one of the things that we have to worry about is wanting to create spaces that don't off-gas, but we also need to think about whether the products are going to perform. And honestly, there is debate as to whether or not the products that stink perform better than the products that don't stink. You take the stink out and the performance goes away. So that's what we have to weigh.
And this is what we actually have to go through. Part of what we have to go through, we have to look at the material safety data sheets for every one of these and look for that, and hopefully it'll be that, but a lot of times it isn't, so we have to reference the guidelines. But now, back to data. Shut up the rest of the time.
All right, so real quickly, this is a heating air conditioning unit. You got your ductwork pulling air from the space, heating it or cooling it depending on time of year, and then it comes down some ductwork and it comes out the grills that we have here. And if this was one room, having one thermostat obviously wouldn't be a big deal. But let's say each one of those grills represents a room. And you only have one thermostat. How many people would you think might get upset if you got one of your offices without the thermostat? Pretty much.
As long as the thermostat's in my office, that's fine.
So Amy would be happy to train out the 200 she told us to so what are some ways we can alleviate this problem?
Well, have thermostats in each room.
So we have systems now, like we have in this room, in this building, and clearly, for almost each room's going to have its own thermostat.
Now, the challenges are the cost, because obviously it costs more to, instead of, with the distribution, sharing it, you have to have more distribution. Obviously, thermostats and the controls for that are expensive. So again, we have to weigh all this stuff. That's me. One of the things is you get credit for connectivity to the outside. It makes you feel good. I know I feel better on a sunny day than I do on a rainy day. And so here's an example of, I'm not sure, Robert, where you took this.
That's Weinstein, fourth floor, and that's Weinstein.
Okay. In Weinstein Hall, here's an example. I asked him to go take this picture. It's a dormer. Now, if you were further into the room, you might get a hint that there's a view, but you wouldn't be able to see through it because of the angle. Whereas in this room, or a room like this, you can walk anywhere around and get connectivity. So to get this credit, you've got to have like 90% of the spaces have to have direct line of sight to the outside. And what we did with Quealy is, here is Quealy, and you can see the old business school. In the old business school, there are a bunch of dormers. Now, where there's dormers, you can't see in all aspects of the room. What we did with this design was we moved the roof higher and got rid of those dormers. So based on that, what do you think? Can we get this or not? Yeah, very good. That was our goal. And here you can see what the effect is. You draw a line from one edge of the corner to the other and project it out to the wall. And so only the spaces that are red are areas that you cannot see. So, with that, we get the Innovation Design credit for a lead accredited professional, and that's us. And Dave.
One thing they don't tell you when you become a lead AP is when you do, you automatically become a celebrity.
So with that, we're done. If there